All right, so we're going to go ahead and move on and cover the synthetic division section of Unit 6. And this is very similar to the long division section we just got done doing, in that it helps us to factor polynomials, and it also allows us to see if what we're dividing by is a factor of the polynomial or if it's not a factor. And remember, that's determined by whether or not we have a remainder. So if we have a 0 remainder, then it is a factor because it went in evenly. If it's got any remainder other than 0, then it didn't go in evenly and it's not a factor. Okay. Now, synthetic division can only be used when we're dividing by divisors that look like x minus c. Okay, so x to the first power and then just plus or minus a number here. Okay, and we use the solved version of this. We use the 0 or the solution that comes from this factor. So if I were to set x minus c equal to 0 and solve, I would move that c over by adding, right? And I would end up with x equals c. So this is what we are going to use when we do synthetic, okay? So let's look at our examples. Okay, first thing we need to do is we need to take our factor, right, just like we had here similarly, and solve it to see what the root or the value is that we get when this factor, this divisor, is solved. So if I were to set x minus 6 equal to 0 and solve, I would get x equals positive 6, right? So I want to use positive 6 in my synthetic division. So here's how synthetic division works. Whatever you get when you solve that divisor, you're going to put that value in a little box, okay? And then we're going to write out all the coefficients of all of the terms of the polynomial that is our dividend, okay, or that would be in the division house. So notice here, we're not missing any terms. It goes from x to the 4th all the way down to the constant term with nothing missing. So I'm going to go ahead and write out just the coefficients. So the coefficient of my x to the 4th term is a 4. The coefficient of my x cubed term is a -1. The coefficient of my x squared term is a 3. The coefficient of my x term is a 2. And the coefficient, or sorry, my constant term is a -5. Now I'm going to leave enough room to write below these numbers, and then I'm going to put a line. Okay, so here's how synthetic division goes. We bring down our first coefficient, our leading coefficient, right, which is a 4, and then we take whatever number that's here below the line and we multiply it by the number in our box. So 4 times 6 is 24. So we put 24 up here under our next number, and we just combine straight down. -1 and 24 gives me a 23. And then we do it again. The number below our line times the number in our box. So 23 times 6 gives me 138. 138 combined with the 3 gives me 141. And we do it again. Whatever the number is below our line times the number in our box. So 141 times 6 gives me 846. I combine down, which gives me 848. And then again, the number below my line times the number inside my box. So 848 times 6 gives me 5,088. And then I combine down. So when I combine with a -5, I'm going to get 5,083. Okay, so that's the whole division process. The biggest thing that you have to know when doing synthetic is, so what does that mean? What is it that we came up with? So this last number here below the line, this is our remainder. Okay, the next number over is our constant term. The next number over is our x term, and then our x squared, and then our x cubed. However many numbers we have, we just keep going up a power of x. Okay, so what's under here is actually our quotient. So if we want to know what this polynomial divided by this little polynomial equals, our answer is down here below the line. We ended up with 4x cubed plus 23x squared plus 141, oops, 141x, sorry, plus our constant term, 848. And then remember, we write it as our remainder over our divisor. So plus 5,083 over our divisor, which was x minus 6. Okay. So we just leave it like that. So this is a much easier way than doing long division, right? However, before you get super excited, on your exam, there will be questions that say solve this using long division and solve this using synthetic division. So I'm going to grade you based on how you worked it. So make sure that you know how to use both methods, okay? All right, so let's look at another one. Let's look at another one. We still need to make sure that both of our polynomials are written in descending order and that we're not missing any terms. So notice if I look at this one, I'm actually missing an x squared term, right? Missing x squared. So just like in long division, I have to fill in with 0 placeholders for any terms that I'm missing, okay? So I need to determine what's going to be the number in my box. So I take my divisor and I solve it. X plus 1, if I were to set that equal to 0 and solve, I'd get x equals -1. So I'm going to go ahead and put -1 here in my box, and then I'm going to write out all my coefficients. So the coefficient of my x to the 4th is a 1. Coefficient of my x cubed is a -2. I don't have an x squared, so I'm going to put a 0. And I don't have, I do have an x, which is -1. And I do have a constant term, which is 12. Okay, leave room to write and then put your line. So I bring down my first value, which is 1. 1 times the -1 in my box is -1. I combine down, which gives me -3. -3 times the -1 in my box is +3. So I combine down to get +3. Now +3 times the -1 in my box is -3. I combine down, which gives me a -4. -4 times the -1 in my box is a +4. And I combine down to get 16. Okay, and then I just need to label what these mean. So remember, this is my remainder, this is my constant, this is my x, this is my x squared, this is my x cubed. Okay, so that means that this division resulted in this quotient. So we get x cubed minus 3x squared plus 3x minus 4 plus my remainder 16 over my divisor x plus 1. Okay, and just like before, if we have a remainder, that means that it's not a factor. So I can actually write that on both of these examples, right? This means that x minus 6 is not a factor, right? And it also means that x plus 1 is not a factor, okay? But there is one other cool thing that synthetic does tell you. If this were a function, this big polynomial or this big polynomial, if you were to take this x value and plug this 6 in everywhere you see an x, what that would equal is equal to your remainder. In other words, if we're saying this is f of x, then this means that f of 6 would equal 5,083. Okay, same thing down here. If this original dividend polynomial here was a function, if this was our f of x, and we were to plug in -1, if we did f of -1, instead of having to plug in a -1 everywhere we see an x, we can just do synthetic. And whatever you get as your remainder, that is what the function value is evaluated at that synthetic value of x. Okay? So just kind of a neat additional add-on there. All right, let me do one more and then I'll have y'all try some, okay? All right, so on this one, again, first thing we want to do is solve our divisor. So x plus 8 means that I'm going to get x equals -8 if I were to solve it. And I need to make sure I don't have any missing terms. And notice here, I don't have an x cubed and I don't have an x squared, right? Missing x cubed and x squared. So I need to put zeros in for both of those. So I'm going to go ahead and put -8 in my box, and then I'm going to write out all my coefficients. So my x to the 4th is a 1, my x cubed is a 0, my x squared is a 0, my x is a -11, and my constant term is 25. So I'm going to go ahead and do synthetic. I'm going to bring down that 1. 1 times the negative 8 in my box is negative 8. 0 and negative 8 gives me negative 8. Negative 8 times the negative 8 in my box gives me a positive 64, which when I combine down gives me 64. 64 times the negative 8 in my box gives me negative 512. Negative 512 and negative 11 gives me negative 523. And negative 523 times negative 8 gives me a positive 4,184. Got kind of big, didn't it? And then we combine that with the 25, which gives us 4,209. So remember, this is our remainder, this is our constant, this is our x, this is our x squared, and this is our x cubed. So what we have learned from this is that our remainder is equal to what we would get if we were to plug negative 8 into this function, right? If we say this is f of x, we have learned that f of negative 8 equals 4209. We also know because we got a remainder that's not 0, that means that x plus 8 is not a factor, right? So these are just 2 additional facts we get from synthetic, right? If we were to plug in this x value into this original, it would equal our remainder. And because we have a remainder, we know that that divisor is not a factor, okay? And then we're just going to go ahead and write out our answer. So we end up with x cubed minus 8x squared plus 64x minus 523 plus our remainder, which is 4209, all over our divisor, which was x plus 8. Okay, all right, so there are 2 for you to try. If you have questions, just unpause the video and we'll work through them. All right, so when we look at number 1, we solve our divisor first, which gives us x equals negative 4. So negative 4 goes in our box. We bring down our 1. 1 times negative 4 in our box gives us negative 4. Combine down to get negative 4. Negative 4 times the negative 4 in our box gives us a positive 16. Combine down, so on and so forth. We should end up with a remainder of negative 1,245, which tells us that this divisor is not a factor. It also tells us that if we were to plug in negative 4 into this polynomial function, it would equal negative 1,245, right? But for the sake of doing synthetic, that means that our quotient here, x to the 4th minus 4x cubed plus 20x squared minus 80x plus 131, and then I forgot to write in my remainder, excuse me for that, we should have plus a negative 1,245 over our divisor, which is x plus 4. Okay, so if they just ask for the quotient, you can give just this part. If they ask just for the remainder, you can give this part. Otherwise, we're going to write it as quotient plus remainder over divisor. Okay, same thing on number 2. We need to put in 2 0 terms. So because we don't have an x squared and we don't have an x. Notice on the first one, we didn't have an x to the 4th and we didn't have an x squared. So make sure you're always putting in 0 terms if you're missing things. Okay, all right, so same thing. Solve the divisor. We get x equals 9. 9 goes in the box. Okay, bring down your first number. 1 times 9 in the box gives me 9. Combine down, I get 9. 9 times 9 in the box gives me 81. So on and so forth. Our remainder here should be 724, which tells us this is not a factor. Okay, our quotient is x squared plus 9x plus 81. That's what we're left with here. And then the remainder of 724. Okay. All right, so that is the end of synthetic division. So you should now be able to complete that assignment on your Knewton Alta homework. And I encourage you to do that as soon as possible, because the next section that we're going to be covering is going to use a lot of synthetic division, like a lot. It's going to be something we do over and over and over as steps to these new problems that we're going to be working out. So it's important that you go ahead and do this homework before we move on to the next section. Okay? If you have questions, let me know.